the ATA that we will, I think, as Professor Rajib suggested, that we will look kind of assessment soon in the IR. I think that will be withstand the flood. Professor Atta, just one message. I got a message from the Secretariat of perhaps this forum. They have sent you an email and inviting you as a guest to make a very brief 1 or 2 minutes remarks after this session at the closing ceremony. So if you could take a look on the email and then be sure that they will call you to give your remarks for about this conference, this forum. Yeah.
Okay. Sure. Sure.
And Atta, many congratulations for being promoted full profession. Thank you very much. And,
congratulations.
Really deserve it so much. We are very, very happy.
Thank you, sir.
That.
Thank you, sir.
Excellent.
Thank you
Excellent.
all my respected seniors and mentors. Thank you very much.
Only we can start
and
now.
I do hope.
Yeah.
Yes, sir.
Yeah, we can start. Well, dear colleagues, good afternoon, good morning, good evening for Dr. Bapong. Welcome to this session on harness technology, data, and knowledge for risk reduction. As you know, this is the one of the latest sessions that in this global forum on this digital technology advanced achievement of SDGs. I assume that some of you has attended other sessions, but today is a session jointly organized by DBAR, Digital Belt and Road, and the IRDR. And I have Professor Rajib Shaw is our dear friend, dear colleagues, and myself. I have the honor to chair this session. You all have the concept note that prepared by the Secretariat, but basically we would like to, by bring together the national experience, the experience from the regional cooperation, and some work on the international level. We want to see how the technology, digital technology and data sharing, knowledge sharing can improve and help for the disaster risk reduction. And this is under the new global movement toward the open access, open science. And I think we need to see from our experience how the digital technology can also help to integrate our expertise, our knowledge, and our scientific findings for a better decision making. So today, for this session, Rajib and myself will chair it. I will start introducing we have 7 excellent speakers. We will start by Dr. Suji Lee, the Director of the Satellite Application Department from the National Disaster Reduction Center of China, Ministry of Emergency Management of China. And her title of presentation will be Satellite-Based Earth Observations for Integrated Disaster Risk Reduction in China. Then we will have Professor Atta, congratulations, Professor Rata Rahman, the Chairman of Department of Geography and Geomatics, University of Peshawar, University of Pakistan. This will be followed by Dr. Amud Mani Dixit, the National Society for Earthquake Technology from Nepal, NISET, the NSET. The hazard on the presentation, hazard assessment and exposure of modeling using digital data in the Himalayas and experience of Nepal. Well, where I'm seeing this, please, dear colleagues, please turn on your camera so that Fang and Wang Lei can take a picture for all of us. Then we will have a presentation from Sri Lanka by Professor Dipsi Viran on the when. The title of the presentation is When Technology and Citizen Science Meet to Manage Disaster Risks, Opportunities and Challenges. So these are the national exercise, then followed by the potential of an open access to satellite data for flood extent identification by the Mufasha Mohammed from our IRDR, the Institute Center of Excellence, Sudbury University, Sudbury University of Kembasan, Malaysia. Then on the regional scale or global scale and multi-hazard early warning systems, the Dr. Bapong Fahruddin, the technical director from Token Taylor, will talk about the disaster loss data accounting to enhance impact based early warning and early actions. And then we will have a UNESCO Professor Wang Jianle, the director of UNESCO Disaster Risk Reduction Knowledge Service sub-platform that is the Category 2 Center of UNESCO on Knowledge Service approach for disaster risk reduction. I think since we have 90 minutes in total, then each speaker will have around 7 to 10 minutes of talk, followed by some quick Q&A. And then if time allows by the end, we will have some brief discussions, and possibly we can also bring up the some recommendations. The Secretariat, Dr. Wang Lei and Dr. Chen, and Ms. Chen Fang, Ms. Lin Fang, from here will take note of your presentation and the questions. Fang, have you taken the photos for everyone? Excellent. Okay, with this, can I over to Professor Rajiv Shaw to chair the rest of the session? I hope this is a clear start. Thank you. Professor Dr. Li, Dr. Li Fuji, please, it's your turn.
Thank you, Professor Han. Thank you. It's my pleasure we can meeting here to harnessing discussion how the harnessing the technology for disaster risk reduction. So I just want to share some experience, not only experience, perhaps some is a license there to about our daily work recently. So the title will be Space-Based Earth Observations for Disaster Risk Understanding in China. I'm from the National Disaster Reduction Center of the Ministry Emergency Management. It's a new built ministry in 3 years before. So this is a number of disaster last year. We can see that the top 10. For the top 10 disaster affected population, China is the first one. For the disaster affected mortality, China is the fourth one. For the economic loss, China is the eighth one. That means indeed China is a country with natural disaster mostly happened and suffered a lot. That even now, 3 days before, a Luding earthquake was happened. This morning they caused more than 80 persons death toll. Still, the rescue is on the way. So disaster and disaster risk is a common challenge for all of us. We all know that along with the 7 targets of standard framework for disaster risk reduction. For the understanding disaster risk is one of the 4 priorities. And also for the 7th target, namely to improve the early warning system, is also very detailed to mention that to increase the population to accessible the risk information there. We all know that, and also from 2018, Chinese government giving very big changes on the concept of disaster management. That's meaning transfer disaster post damage assessment to mentioned and mainly focus on the disaster prevention there, and covered the whole process there. And also for the under the disaster or emergency system of the national, Earth observation always been addressed since perhaps almost 20 years before. For the recently published National Emergency System, the satellite emergency and application has been also highly addressed, and also for the risk monitoring and early warning has been pay more attention there. And in terms of the observation satellites of China, is from the number to the types has been increased and developed very fast. Now there's more than 20 satellites is onboarding there. And from the spectrum covered from the infrared and visible band to different size, like C band, L band is there. So make it possible that perhaps we not only observing the very large covered areas, big changes, perhaps can using for some detailed risk element there. So I just want giving 3 examples. We are now been working to try to using the Earth observation data to do the risk monitoring. The first one is forest fire. In fact, daily we're doing the we're doing the hotspot observing for the covered China, and also periodically to observing the not only forecast but also is dried leaves there. And for the hotspot area, using the hourly observing for its higher temperature point, and if there's forest fire happened, then using the infrared for hourly monitoring of that area, and then can also using the 14 meters resolution satellite for daily observing there. So for the forest fire, now is for the whole process could be observed from the risk element to the emergency whole process based on the observation there. And another example is about a comprehensive risk element monitoring. It is example about the Winter Olympic period area, and you know that there's more than two years prepared for the Olympic Games, and there's 3 points for the games there. So we're using more than 10 satellites. 12 every 2 months, we're doing the daily monitoring about its water coverage for an nearest reservoir, for its water volume calculation, and also during the winter we monitoring the snow covered coverage changing, and also using the HD satellite thermal red bands to do the land temperature monitoring. And also for some point where has been a landslide disaster happened in history, we doing the ground deformation observing. All those kind of observing is for find the some abnormal element is information there for furtherly going to the risk analysis there. This is the second example. For the third one is last month, there's a Matsbach ice lake. It is ice lake located in Kyrgyzstan, and but it's along a river upstream of China. So annually, according to the statistic of the last 100 years, 80 years has been broke of the band during of its dike in July, and also sometimes causing flood inside Chinese is inside there, and in the downstream there's some power station there. So about 2 weeks before, in fact, there's we're observing the lake for its lake area, and also for the ice distribution, and also for the hydraulic that area is river band. So 2 weeks, almost daily, we're using different satellites to observing from upstream to the downstream. And on July 17th, the ice lake has been broken, and also the water of the ice lake coming to go to the power station there. So in fact, along this process, for the power station of the reservoir, they also do some solutions and also some do some measures to prepare for the water. That's why it's a very great, a very successful example to prevention one kind of flood. Here is two image of the earthquake. Now it's ongoing. In the almost 1 p.m. Beijing time, the earthquake happened. After 6 hours, we're having this, because until now, the earthquake affected area still cloudy and raining. So the optical satellite is invisible. So we're using, now there's 4 satellites. So we're using the satellites to do the dynamic monitoring of that area, find more than 20 landslide, and also and more than 10 landslide caused the route has been blocked. And also now the emergency monitoring is on the way. But this is two image on the web and produced by 2 Chinese team based on Sentinel satellite image. About one is from the deformation, one is from the change detection. And I hope that perhaps one day we could do more for the earthquake is risk, but now is not on the way. But I think that we could work together, do more this kind of risk, and for better early warning of the earthquake based on more and more types and numbers of Earth observation satellite, and for better early warning of this, and then reduce the risk and losses there. So that's my reporting here, dear Chairman. Thank you.
Thank you very much, Dr. Lee, for your very good presentation. You have demonstrated the Earth observation technologies in the application of forest fire, the reservoir lake management, including the ice lakes in some areas, the landslide observation, and some hydro engineering project, which has also a transboundary risk issue, which I think is very, very useful. I don't think we will have, if any participant have a very quick question, otherwise we will proceed with the next presentation. And then by Dr. Lee, please stay on. Maybe after the all presentations, there will be questions to you from colleagues. Okay?
Okay, thank you.
Okay, thank you so much. Thank you, Dr. Lee. Then Professor Atta Rahman, the chairman of Department of Geography and Geomatics, University of Peshawar University. The floor is yours. And first of all, we wanted to share our sympathy and the concerns about the impact of the populations by the recent massive flood. Professor, you have the floor.
Thank you, Professor Kunlia, for giving me the opportunity to be part of this very important event and to learn from the actual intellectual responses of our worthy colleagues and scientists. The title of the presentation is Transboundary Hydrology, Climate Change and its Impact on Flood Factors in the Kabul Swat Floodplain, Pakistan. This study, particularly, it was selected transboundary hydrology. The focus is on the Kabul River. The Kabul River is actually located, spread over two countries, Afghanistan and Pakistan, with more portion of the basin located in Afghanistan and a small portion, less than half, it is located in Pakistan on the eastern side of the Durand line. So this is the transboundary hydrology, very interesting transboundary hydrology. You can see here on one side, there is Pakistan, and the other side, there is Afghanistan. Interestingly, some of the rivers, like you can see Chatral River, it takes its origin from Pakistan, it entered into Afghanistan, and then from Afghanistan, it joined the confluence with the Kabul River, and then finally it entered into Pakistan. So this river system, Kabul River system, it takes its origin from the Hindu Kush Mountains. So you can see here the drainage basin map of Pakistan, Kabul River system. So if you look into the discharge data, almost 60% share it comes from Afghanistan, whereas the rest, almost 40% share it comes from Pakistan. This is very interesting because in Afghanistan, so many dams have been constructed on the Kabul River, and there is water diversion from the main river. And there is decreasing discharge trend in the downstream areas. The transboundary hydrology and its management is always a challenge for the riparians. The upper riparians, they demand maximum utilization of its resources, whereas the downstream riparians, they are also needs some intentions, some requirement of water as well, because large communities depends on this Kabul River basin water. This has often resulted in a unilateral use. The upper riparian, they have a unilateral utilization of the water resources, and it seriously affected the downstream communities. Multiple factors contribute to water crisis, including the rainfall variability in the catchment area, the snowfall occurrence in the catchment area, because in the Kabul River system, we have calculated 2,000 glaciers, small and large glacier, it fed the Kabul River system. 2,000 small and large glaciers, it fed the Kabul River system. It's very interesting transboundary hydrology. Sometime in this drainage basin, we have floods. In the upper stream areas, we have flash floods, very destructive and devastating flash floods. Whereas in the downstream areas, in the plain areas, we have riverine flood characteristics. And then another part is the drought. Sometimes because of little discharge in the Kabul River system and drought situation, there is another very important factor is the urbanization, means people are regularly converting the built-up area, agricultural land into built-up area, and people are cutting the forest ruthlessly, and they are converting the same into agricultural land. And then the agricultural land is converted into built-up area, either to the housing conditions or to the housing or residential areas or commercial areas. In both the countries, the population growth rate is enormously or exponentially increasing. I mean, the population is increasing day by day, and they need shelter. So therefore, the land use is gradually changed from the green agriculture and the vegetation cover into built-up areas, means green into gray structures. Transboundary water basin constitute around 40% of the world population. I means throughout the world, almost 40% of the world population that depends on the transboundary hydrology. So the Kabul River system and Indus River system, Mekong River system, Brahmaputra River system. So these are some of the typical examples of the transboundary hydrology. This includes 286 international transboundary river basins. Some are large, some are including 151 countries of the world. So I mean, is very important areas. And this transboundary hydrology is typically addressed in the Sendai framework for disaster risk reduction. And similarly, Hyogo framework for action, it was also addressed in their framework as well. So transboundary hydrology, it is an emerging area and called for the scientists to work on this particular area. Using the SRTM data, different sub-basins have been developed. You can see here the different sub-basins, the upper basins and then the lower basins. Every basin has its own characteristics. Some are the central basin where it is occupied by a large number of population and high population density, including Peshawar, where Peshawar University is located. It is also the surrounding area is drained by this Kabul River system and its tributaries. This is a map showing the spatial variation and spatial distribution of the soil cover. Different types of soil texture is reported from the Kabul River basin. On both sides, the catchment area or the boundaries of the Kabul River basin, it has been subsetted from the satellite images. You can see here on one side the 1991 satellite images, and the built-up area and barren surfaces, it is gradually increasing and multiplying day by day. So I mean, the barrenness or the residential areas, it is increasing day by day. They are cutting the vegetation cover and the greenery is replaced by the gray structures. So it is one of the most important challenging area for the scientists, and it needs land use regulations so that people should not convert the greenery or the food basket land which feed the population in these developing countries. So it calls the scientist to work on this particular issues, because when you are losing the vegetation cover, the forest cover, obviously it will have serious repercussion on the flood discharge. It has been estimated that there is almost 60% less potential of floods as compared to the areas which is under vegetation cover. So vegetation cover in the catchment area, it reduced almost 40% flash floods and riverine floods in the downstream areas. But this is one of the challenging area where we are consistently losing our green land use. In these two countries, particularly in the Kabul River Basin, there is rapid conversion of the greenery, and the built-up area is occupied. So you can see here the population density in the areas. So you can see there is rapid concentration of population in the basin area, and the same has been predicted for the future as well. Similarly, the same water resources which is present in the Kabul River system, it was correlated with that of the population and water availability, means fresh water availabilities. So you can see here in 1985, you can see the cross area. So there is gradual decrease in the water availability, per capita water availability, and there is gradual increase in the area under population. So means population is gradually increasing and multiplying day by day, and we are losing the water availability in the area, which need proper water management. Kabul River Basin, you can see here it is almost 72 kilometer. It takes its origin 72 kilometer west of Kabul city from Kohebaba. Kabul River is 700 kilometer long. I mean, it is one of the longest river as well, flow in the eastern Afghanistan, and finally, the same Kabul River, it confluences with the mighty Indus River in Pakistan. River Kunnar and Chatral, it represent about 12% of the total water available in Afghanistan. This Chatral River is taking its origin from Pakistan. It entered Arandu in Afghanistan. The total inflow of water from Afghanistan is 21.5 cubic kilometer, including maximum share of Pakistan.
Dr. Atta, please accelerate a bit because of time.
Okay, I will wind up within few minutes.
Yeah.
Okay, thank you. This is the Kabul River Basin, and these are some of the major dams which is either under construction or already completed. This you can see here in Afghanistan. These are some of the almost 30 dams have been constructed in Pakistan and Afghanistan. You can see here some are proposed, some already completed. But you can see here in Pakistan almost 30% dams. If all these dams have been constructed, obviously it will have impact on the riparians and the downstream riparians as well. So these are also the sub-basins of the Kabul River Basin, both in Afghanistan and Pakistan. And the special distribution of dams, you can see here, this triangle shape, it represents the distribution of dams located in the upstream areas and the downstream areas. You can see here another map showing the distribution of proposed dams and the existing dams. Because of the heavy discharge in Kabul River system, it continuously changes its course. So you can see here in 2015, 2005, 1995, 85. I mean, during 20 years, the changes have been occurred in the water courses as well. So the area is already occupied by high population settlements. So this is the flood susceptibility map showing the various zones. This is the prediction for this next 50 years for the Kabul River Basin. This is prediction, means the mapping for flood return period for 80 years return period for the Kabul River in Peshawar Valley. This is for 120 years return period. These are the maps showing the distribution of temperature in the area, average temperature in the catchment area of Kabul River system. These are the rainfall distributions. And this is the snow cover. It is gradually decreasing in the catchment area, so means there is little discharge, and intensity of rainfall is increasing. So you can see the accumulation of snowfall. It is comparatively low availability during the summer period, June, July, August, September. These are the distribution of the, showing the distribution of glaciers in the catchment areas. So this was another study carried out on these glacial lake outburst floods. It is another flood contributing to the community discharge. You can see here past 30 years data have been compared, and the Glough susceptibility analysis, it was carried out in the Astur drainage basin. I'm going to the, so these were some of the parameters which have been used for carrying out the susceptibility analysis. Again, some other parameters. So all these parameters combine to form the susceptibility mapping. You can see Glough susceptibility maps of the Astur drainage basin. And then the potential glacial lakes. Where are these lakes? You can see the distribution with the asterisk marks. Over there, these are the some risk mapping already carried out in this area. Some interesting study was also carried out for dam construction, suitable sites. I'm going to wind it up in 1 minute. Then you can see some parameters. Almost you can see here 6 parameters were identified, and the dam sites, it was suitable site. It was selected where to build the dams in order to cope with the flood discharge in the catchment areas. So with these words, thank you. These are some of the concluding remarks. Thank you.
Thank you very much, Professor, for your very rich presentation about the Kabul River Basin transboundary water hydrology risk, the issue, very combined issues of flood and drought, and the environment changes in terms of population, the forest coverage, and so on, and also your studies in the change of the glaciers. Thank you very much. And we will, in the interest of time, we will go next one for the presentation from our good friend, Dr. Amod Mani Dixit from Nepal. Amod.
Mute. Thank you very, very much. Let me go for this presentation. Okay. So it has been, thank you very much, Julie, for this opportunity, inviting me. I'm presenting here the work done by NSET, which I am as a president. And our colleagues are here. I see that Sarad Wagle is right now in Canada, and he has also joined in. So this is a work collectively by the colleagues at NSET. I am presenting this presentation. Now, what is this all about? You know, after the 2015 Gorkha earthquake, it was something like a watershed in disaster risk reduction understanding in Nepal. Before that, NSET used to work focused mainly on earthquake. And although we started going multi-hazard, but then life dictated us to go multi-hazard after the 2015 earthquake. So this is something like an account of what and how we are using the various technologies for our hazard assessment and understanding the risk due to disasters, due to different hazards in Nepal, and how to use the digital technology or the Earth observation data slowly for improving our understanding. But to go back into history, very early in the early, start of this millennium, we started thinking about, the database. So we used what we call this inventar, and that was our first encounter with, working with the data and having a, understanding of the disaster in a comprehensive way. So we used the system, and we have got data. NSET collected their data, and we have received a collaboration from UNDP, and up to now we have been monitoring it annually and publishing that in website together with the UN system. Now with that, I mean, we have got this data. I am not going to go into details, but this shows that we are one of the most at risk, at a high hazard for different forms of geological hazards. But then the earthquake happened, and then we were absolutely, impacted by landslides, and there were many landslides. And there was a need for understanding, and the people were suffering, and they were trying to find out where should they go. So it was almost like it was a pressure onto the Nepalese to identify, understand the landslide process and others. Luckily, we had our collaboration with Durham University, the Institute of Hazard Risk and Resilience. We were working on more academic area, bringing in students and teaching them. But then we could quickly, divert ourselves into more academic study to a response study for landsliding, and we were surprised. Where we focused on 14 districts, the most affected one, and we were surprised to see the dynamics of the landslide. What we see is that the earthquake triggered immense, volume of landslide, and that in that affected districts. But more importantly, the activity or the dynamics of the landslide, it continued for several years. And to come back to the normalcy, it has not still come out. What we see is that the earthquake triggered landslide that was perhaps equivalent to something around 200 years of landsliding in that 14 district area. And then what we see is that together with the co-seismic landslide, together with the co-seismic landslides were the one that happened by rejuvenating the existing landslide, but then also triggering many more newer landslides. We have been using the satellite, information or data interpretation for understanding these dynamics by analyzing manually pre-monsoon or pre-precipitation or epoch with the post-monsoon epoch and comparing the dynamics of the landslide. You can see the map in the lower portion of that area. But then what we see is that, doing that is too slow. Landslide has been occurring, and then the earthquake has triggered, it has made it more frequent, larger, and people are suffering. So we need to have a quicker way of understanding the landslide, and because the value of information on landslide, it evolves very rapidly. So then life dictated us that we need to go for automated processes. And then again, with the Durham University, the Institute of Hazard and Resilience, with financial support from the Global Challenge Research Fund of the UK government, we continued the process, and then we started manually interpreting the Landsat 8 and Sentinel, the space data, and started mapping it. But then that was also very slow. So we continued, thankfully that the project was continued to be supported. And then we continued from, extending from 14 districts where we have got accumulated a lot of knowledge about the dynamics. Then we extended it to other parts of Nepal, using the same manual combined with the interpretation by taking the training area and understanding it and extrapolating that information or the knowledge. So we have been able to create almost like we have covered the entire country, and we now better know about landslide using the Earth observation data, using the satellite technologies. So now we can see that we have got many major landslide incidents collected and in the period since 2018 to now, and then we were tempted to use that data for this better understanding how to share with the people. So one of our colleagues, he did a PhD in Durham University, looking into the social and psychological and economic aspect of this landslide. And what he found is that, talking with the people, unless people who are at risk or who have been affected, without their involvement, it is almost, not very productive to do the disaster risk reduction in terms of landslide. So in that course, he developed equivalent to what we call the NSET's SHET table. He has developed this landslide demonstrator, which is, which uses this is a physical model that creates landslide, induces landslide with precipitation, without precipitation. And when the terrain is developed in this landslide demonstrator, if, people could identify their houses or their location, and they are involved in the creation of this model, this makes wonder in terms of people's understanding of the phenomena. And now that they understand the phenomena, they can devise or they can think about what could be the solutions for their landslide risk reduction. I'm stopping perhaps at that. This has been very dramatic, perhaps as dramatic as our, the sectable demonstration for our earthquake building collapses. And then we also use this, the 3D cutter for developing the model. And in rural areas, such 3D model make wonders because people identify themselves with the environment, with the location, and then their thought processes start, it gets triggered and they start thinking, more, with a small scientific guidance, they can be even better solution. They can have better solution than we guys, the landslide experts.
2 more minutes.
So with that, we then again, expanded further from hazard to risk evaluation, and then used again Earth observation. And this time we're using the opportunity by another the Global Challenge Research Fund of the UK government, and then make an assessment using the local available data to go for a risk assessment. And now this has gone into the policy making process. It is being, number one, it is open source, everybody can have it. And then it has gone into the policy formulation process, and then in the capacity development and others. I don't want to go into details because I don't know much about this detail, but this is a big progress for us. And it has got into the National Portal for Disaster, which is called BPAD, run by the National Authority for Disaster Risk Management. And then together with this all data, satellite and also physical data, we used scenarios. We developed different scenarios, daytime scenario, nighttime scenario for earthquake, for exercises done by our civil and military part of our, together with the US Army. So all this information, we are very proud that this is it's a change, a very positive change in our understanding, also in the use of the satellite technologies, the digital technology, and also propagating the technology to the people. And many of the information are available in these sources that I have cited here. So I stop at there. Personally, I'm very happy to be again back into this disaster discourses. I was a little bit away from the stage for some time, and I'm full-fledgedly coming back to this this area again. So thank you very much. Thank you for your patience in listening to me. I'm ready for any questions, which perhaps Sunli said that it will come in there towards the end of this session. Thank you very much.
Thank you so much, Dr. Ahmad, for your excellent presentation. You highlight the challenge that the landslide affected areas and how unsatisfactory in terms of the slowness in making a surface and assessment. under the effort and the progress you have made in assessment of the landslide and sharing the data, make a technology and the new findings available to the communities. And the last slide you showed is the sharing of all the sources of the data publicly. That I think is excellent. So with this, I would like to hand over to the chair, Professor Rajiv Shaw. I'm sorry that the time control, I'm not very good, but so now it's your turn.
You are very kind, Chunli. Thank you. Thank you very much. The sad part of Amod's presentation was that I could not see his facial expression when he was speaking. Now he has put on his camera, because Amod, when he speaks, his face is so passionate about what he is speaking. So we actually missed that, but maybe we will come back to that in the QA session. So thank you, Amod. We go to our next presentation, which is from Dipti, our good friend from Sri Lanka, and which is again one of my actually very favorite topic, which is on the citizen science in the disaster risk reduction. So over to you, Dipti, and if you can stick to 7 to 8 minutes. Thank you. And if you can switch on your video while speaking. Thank you.
Thank you very much, our good friends. I can see a lot of them. Thank you very much, Professor Quinley and Professor Rajiv, for this opportunity. And my talk today is on when technology and citizen science meets to manage disaster risks. So I'm going to talk about some opportunities and challenges. I did this research with one of the co-authors, Prasadari Ransinga, from the same department. Now, everywhere we see today struggle for power. But my argument is information is power. When it comes to disaster management, the disaster management benefits from growing accessibility and availability of many sources such as technology and data. At the same time, availability of reliable and relevant information and data are very essential to reduce disaster risk. And let's see how. Now, according to the Sendai framework of action, it has specifically highlighted the role of information and data to help achieving the priorities, including understanding disaster risk, strengthen disaster risk governance to manage risk. So for all these things, we need good data, timely data, and accurate data. So the information need takes different dimensions in different situations. So I would like to show you my two aspects, science and big data in disaster management. All the previous, my colleagues talked about the big data, use of big data. As we know, geographic information system and remote sensing, we can do wonders, we can monitor the situation, we can simulate the complicated disaster occurrences, and we can do it accurately as possible. So we can then have better prediction models. We can suggest appropriate contingency plans and so on. So there are a lot of things that we can do using big data and other analytical tools. But my second concept or my second issue is something which we have paid little attention to, the citizen science. This is the social science backed with applied science principles. Now, the practice of public participation and collaboration in scientific research to increase scientific knowledge is called citizen science. This is gaining popularity in many parts of the world. Citizen science is becoming central to participatory disaster management in many parts. Here, people share and contribute to data monitoring and collection programs, right? And they can answer real-world questions, but they need to be guided properly by professional scientists and using established science protocols and tools to gather data. Having said that, I would like to explain it more. when we do citizen science, because we need to visit the places, it's a very good opportunity to see the ground truth of the occurrence and impacts of natural hazards, such as floods and landslides. If you visit the site personally on site, you can meet people, get information from them. So this information could be very important in early warning, to understand the signs of disasters, and you can then really see the impacts. At the same time, we can improve communication and understand vulnerability and risk that the real people, the victims or the citizens face at the ground level. And beneficial in obtaining information on different phases of disaster management cycle. For instance, disaster preparedness, mitigation, we can get their ideas, we can get their opinions. Sometimes these opinions and their voices have never been heard by the others. So one good example is the Sendai framework recognizes the stakeholder involvement. This is what we did, the flood study. Actually, Professor Rajiv too was guiding key personnel on this project. So what we saw was, when we really went to the ground, we saw in each household, the areas on inundation, they have boats. Rather than having a car or a van, they had boats, because they know every year this flood comes and inundate their infrastructure. So the only means they have is the boat. And when we collect data, we found many of these households, they have 2 stories, because the ground story gets inundated twice a year. So then they have all the furniture, equipment, and the belongings, the assets in the top story, and all the electrical connections are restricted to the second story, the top story, because the ground story gets inundated. So these kind of things we don't find, it's very difficult to find using only big data or the modern tools we have. So, but at the same time, we can couple the citizen science to the modern tools to empower. Like, for instance, we can teach them, guide them to use smartphones, mobile applications, web-enabled databases for them to submit their views and observation directly about hazards. And real-time knowledge networks, especially when it comes to disaster responses, it would be very beneficial for the practitioners and the decision makers to take action. So I present 2 case studies. This is actually one I mentioned earlier. We did this study to understand the spatio-temporal landscape features which contribute to increased floods in Kaluganga River Basin. So that is the second largest river basin in the country. You can see some scenes of inundation that happens annually in that area. So what we did was, as my colleagues have done before, we using GIS and remote sensing, we investigated the land use land cover changes in different years, and this is in 2001 and this is in 2020. You can see clearly there's in green the greenery and the vegetation, natural vegetation, that has reduced drastically. At the same time, the red one are the human settlements. The human settlers have increased. So we attempted to link the changes in land use land cover in the Kalu River Basin, and we found a significant relationship between the reduction of the change of land use land cover and the occurrence of and the inundation of floods. Similarly, we did this in Nigambo Lagoon area. It's again land use land cover changes. Again, what we found was more in the changes of wetlands. Wetlands have been disrupted, encroached, filled up, and there's a massive loss of wetlands in the area, which has led to more inundation in the recent years. And they say the duration of the floods, we can see it's increased. Damage to property and livelihood is there. And on top of this, psychological fear and the effects of mental well-being we have observed when we talk to the people. Not actually, what I want to stress here, the highlight here, is the combination of the big data and analytical tools with citizen science. Similarly, this is what we did in some of the wetlands in Colombo. It's in the periphery. It's a huge wetland. And again, we can see from 2001 to 2021, there's a change in land use land cover. Towards 2021, there has been a...
another 1 minute, please.
Okay. So you can see the change and opinions of residents we have taken. But according to the opinions, what we see from the maps is the land use land cover has changed due to encroachment. But what people see is the floods are not as a result of that, but for the because of the less or poor maintenance of the lake. So there's a difference. So the challenges we face, the big data and analytical tools, it's very expensive. Sometimes there's a problem with reliability, inconsistent, inaccurate, and outdated data, lack of integration of different systems, and data limitations, right? So one example is when we from the image, we can see we can't differentiate Mars and water. So, but then you have to go for ground truthing. So when it comes to citizen science, the challenge we see during our processes, the support structure is not there around citizen science, are not fully established and understood. And there's mixed attitudes toward the value of citizen science because some researchers are very skeptic about it, and then challenges in managing the ethics of citizen science because sometimes if the researcher is not fully trained, they don't know how to frame a question and how to present a question. So with this, my last slide is what I propose. We have to combine big data and citizen science, and we have to focus on merging mechanisms, stakeholder involvement, reliable platforms to connect these two different aspects and integrated plan. Thank you very much, and let's work together for a secure future.
Thank you. Thank you very much, Dipti, for this wonderful presentations on the citizen science and also linking it with the big data as well as the remote sensing data. It's a very, very important issue which you have raised, and we will possibly, if time permits, we will come back to this particular issue a little bit later. Thank you. Thank you very much. Our next presentation is from Fasha from SIDPRI in Malaysia. And she will be again talking to another very important aspect, which is the open access satellite data for flood risk management. Thank you. And Dipti, if you kindly unshare your screen. Yes, over to you, Fasha. And 7 to 8 minutes, please.
Thank you, Professor Rajib and Professor Chun Lee. Good afternoon, distinguished colleague. Before I proceed, on behalf of SIDPRI UKM, I would like to thank the organizer for the opportunity to present in the session. I think it's been a while looking to the familiar faces. In the last year forum, we presented about exposure element open access data in disaster database. So today, this year, I would like to share on a work that we currently working, still using an open access data, following to the series of great big flood that happened in the country in December 2021 and January 2022. It is a local case study in Selangor and Kuala Lumpur, Malaysia. So my presentation title is Potential of an Open Access Satellite Data for Flood Extent Identification. It is a co-author work with my colleague, Professor Joy Pereira, Dr. Lim, and Mr. Navakanesh. So I would like to start with an understanding of the various degrees of susceptibility and vulnerability within cities, population group that have differing skills. Housing and socioeconomic statuses play an important role in making a city more resilient. So open access data actually provide a pathway for building urban resilience. Literature has suggested many types of open access data, but today in this presentation, we will focus on the remote sensing open access data. The availability of open access satellite imageries actually offer opportunity to enhance real-time situation management, disaster response, and subsequent post-event assessment. So the increasing availability of satellite images of places present an opportunity to utilize deep learning on these images to provide a preliminary insight on the impact of disaster after its occurrence. Open access imagery such as Sentinel constellation and particularly Sentinel-1 and 1A and B are widely used for mapping water and flooded areas. So Malaysia has experienced a massive flood that affected several states in the country in December 2021 and early 2022, which is in January. Various struggle ensued and resulted in 54 deaths and about 6 billion worth of property damage, and a total of 125,000 people have been displaced. Selangor, especially where you can see located in the box in the map, had experienced record high precipitation during the storm event with several days of continuous heavy rains, and it was among the worst hit states along with Kuala Lumpur. Kuala Lumpur lies within Selangor, but it's two different states. The extreme flood that occurred rapidly and simultaneously at many places in these both states, Selangor and Kuala Lumpur, had left the local authorities struggling to manage the crisis. So at this point, numerous remarkable studies conducted on floods in Selangor and Kuala Lumpur can be found in literatures. Findings obtained from this literature have well served its purpose in facilitating decision-making processes. However, limited studies found to showcase the actual view of the flood phenomenon when it happened. So, in this study, we use Sentinel-1 satellite data as a tool to identify the wet areas, giving an estimation of the extent of inundated areas on low-lying area and moisture-induced landslide prone area on the highland and slope areas. So, the use of these Sentinel-1 imageries actually enable us to perform a post-disaster assessment of the flooding incident during 18 and 19 December 2021. And there are post-processing step was performed for these images in order to obtain the final output that we export in the Google Earth for a better showcasing and visualization of the finding. So this study is still ongoing. So a quick prop of disaster hit areas in Selangor was actually carried out. The satellite image in this slide show a case overview of a local area where we can see a difference between before the flood happened and with the image that the image was taken in November, 27 November, and following to the flood where the image has taken at 21st December 2021. So based on the analysis, evidence of river swelling was found in this image, such as along of this Langat River. So new areas that will be susceptible to flooding must be identified using new approaches considering the impact of climate change. So in Selangor, in this state, other factors were also found in to compound the impact of extreme weather events. This actually includes the coastal area, a high tide in the coastal area, and water treatment plants shutdown that result in water cut in many areas. So moving on to this slide actually shows a locality known as Taman Sri Muda. It's a residential area in Selangor where it was one of the worst hit areas within Selangor during this December flood, which actually displaced over 14,000 people for this area only. So there was huge difference if you can see at the images taken before the flood and also following the flood. The water coverage has submerged the entire area at point 1, 2, and 3. So further analysis can be done to assess the exposed element and social vulnerability within this area. Next is another case study in Kuala Lumpur showing an overview of flood of selected area for before and during the flood happening. So this we have been able to map the area that have experienced inundation during this big flood series. So next is another case in Kuala Lumpur as well that called Kampung Palimbayan. Is also a residential area that was affected by landslide on this 19 December due to the continuous rain. So landslide occurrence are possible in similar setting in the future as a result of weakening soil and surrounding rocks. Similar situation may exist in the highlands of Selangor as well. So, but further studies is needed to observe and monitor this situation. So, from this preliminary work, our finding revealed that wet zone within Selangor and Kuala Lumpur, and by using this extracted information, we can actually perform further analysis by differentiating the permanent water bodies and flooded area to observe the impacted regions. And the extent of flooding can be determined as well as the size of the affected area. Thus, the newly acquired information can be utilized to improve the adaptation strategies within state of Selangor and also Kuala Lumpur. So, coming to this last slide, what we can conclude from this preliminary finding is that the availability of open access local information would actually support efforts to build the resilience of communities that do not have access to information on hazards, and they may not be aware of the emerging impacts to the exposure element that they are depend on. So this study would suggest the relevant authority should consider providing processed satellite images with interpretation for public access in addition to supplying only proprietary raw satellite data. And in the immediate aftermath of disaster, we always know that the primary issue is timeline. So satellite can actually provide rapid situational awareness over a large area, which offer the disaster risk management community a powerful tool to support recovery over these days and weeks that are following a major big event or major catastrophe. So this study is still ongoing. We are still assessing and the processing algorithms and further analysis that need to be done for the findings. We'll be able to share more once the paper is being published. With this slide, I end my presentation. Thank you very much.
Thank you very much, Fasha, for the wonderful and very, very illustrative presentations with very practical application of the open satellite data. Thank you so much. And also keeping it just exactly on time. Thank you very much. Our next presentation is the data man of IRDR, Dr. Bapon, and it's always a pleasure to hear from you, Bapon, and so many things to learn from your presentation, and very much looking forward to your presentations on this enhanced impact-based early warning system. So over to you, Bapon. Thank you.
Thank you so much, Professor Rajib Sam, for inviting me, and it's been a pleasure also to see all these known faces and also some of the very concrete, some of the recommendation and challenges actually that the previous presenter presented. I think that makes my talk a little bit more easier and shorter. And Rajiv would be happy that I could go a little bit less than 8 minutes or 7 minutes, whatever it is. So I'll just try to share with you that how the data ecosystem is quite important for the end result, which is we are always actually nowadays talking about early warning, early action, impact-based forecasting, multi-hazard early warning system. So these are very common wording, and every one of us actually really wants to see that actually that are actually early warning is actually taken by an early action. And if that's the case, we actually need to have quite fundamental few information which need to be triggered those warning to be an action. And such as things is like, you need to understand your overall risk on the hazard. You need to understand what are the thresholds that could trigger the risk. You need to understand the time of onset, what are the duration of the hazard, what are the magnitude as well as recession period so that people can come back to their normal life, and what are the consequences and impact that it could create overall into the different disaster management phases. And having those kind of information, once you have, there are substantial decision making you do in a strategic decision, in a long range forecasting, planning in a medium range forecasting, and operational decision maybe a short range forecasting kind of things. But how we can actually generate those kind of information based on the data that we have, that's maybe the most critical question we always ask. And when you look at the disaster situation, hazard is not actually a single hazard. It creates quite systemic cascading and compounding, so which makes our life more complicated and scenario is more complex than what we have even actually manage ourselves. So this is an example just I put together from the Tonga volcanic eruption, which generated from a volcanic tsunami, ashfall, and then started the pandemic, and how that overall things bringing together flooding, tsunamis, infrastructure collapse, stretch in social life, and at the end of the day, it's a huge death of life, economic loss, as well as death of people. It carries in any society. So how actually we try to understand this differential hazard and their risk, and how we can actually generate next levels of warning system. And when you look at the disaster-related statistics, which more, because nowadays we are actually quite following the global framework, which is Sendai framework, climate change, Paris Agreement, and SDG, and that also generating billions of data sets, because our statistical department, civil defense authority, they're all collecting their loss database, trying to understand it, how the previous hazard happened, but there are actually very less coherence between this SDG data, Paris Agreement data, even in the Sendai indicator. But how much actually we are using those Sendai loss database for our decision-making process, or impact-based forecasting generation, or even actually to understand the climate change loss and damage scenario. Again, you'll see there are big gaps in those three domains. And then looking at the data set, it's for a single hazard, we used to work on a 4-dimensional aspect. You're looking at minute to century, you're looking at global to local, you're looking at hazard exposure vulnerability, you're looking at different horizontal sectors like infrastructure, ecology, economic, human. But when your hazard is actually quite cascading and compounding, this makes more complex dimension. So I try to put it into 4-dimension into a 6-dimensional aspect, and which is actually later modified by the Professor Simlan's framework that she produced on the systemic risk. And here you actually try to look at more about not only the scaling, but also actually the system understanding, transboundary effect, what are the relationship and interrelationship between them, and how actually this outcome could be bind itself together within the time frame that we are looking for. And how actually you get data to feed in each of those domains to better understand and correlate each of those cross-domains. So how we'll be doing those things? Are we still working on this many-to-many, or we need to work on a many-to-one? So it's maybe my question to every one of you that how you want to define your domain standard, how you need to make sure that we can actually try to build up some semantic or data schema, so that actually once our data system actually talks to each other, they have a quite coherence between each of those domains, and one can actually read other. Because at the end of the day, machine need to learn. We need to let the machine or model to learn how to do those things. We need to develop a set of recommendation practice using some coordinated set of domain agnostic standards, so that it makes sure that our data is actually fair, which is like our data is findable, our data is accessible, our data is interoperable, and our data could be reusable by every single domain who want to use those kind of data sets. And I think that's why actually we need to come up with now a CDIF, what we call like a common domain integrated fairness into the data domain. And I think that's how it needs to be moved forward in the future, as our system are quite emerging, our dynamics is quite complex, our domain need to be interact each other. So they need to have some quite standardization in this area. And these are the common dialogue maybe I'm actually giving last 20 years in my life, actually the challenges, and then recommendations again and again. You'll find everywhere that what are the barriers? Barrier is always actually the data management mechanism itself for each of our domain, whoever working in agriculture or disaster or climate change. And then how we can actually manage our data set, because we are not as a data scientist as a domain, but how we actually interact with our data scientists and how they can help us on these things. And then also underutilization and unexplored data set, because often we actually store data, but those are in a spreadsheet in our computer that doesn't go to other people or other common areas. The lack of usability, clear and complete data set, and also data sharing mechanism is a big challenge, because it's still in the organization, we don't share the data set. private sector doesn't share that data set, insurance industry doesn't share that data set. So how we actually solve those kind of puzzles, and how we actually make sure some standard vocabulary and definition is used, because landslide could be a hydromet, landslide could be a geohazard. So two domains can actually play into two different areas, but how we can actually let them know that in a vocabulary and standard definition, those are actually quite well structured so that we better understand our climate and disaster risk with proper exposure, understanding your hazard, understanding your vulnerability, and that could lead to you to understanding your consequence to live that. So nowadays, we are talking about this cross-domain interoperability, and that also need to reflect into early warning system, because when you're talking about cyclone, it's actually a cross-domain area, because you need to have interaction with atmospheric, you need to interact with the ocean dynamics, you need to interact with coastal, you need to work on the hydrodynamics, and then finally the people. So how this cross-domain should work. We try to develop some strategic plan and framework for Caribbean. All the 8 Caribbean actually now have their own framework. How we actually develop a framework for weather, water, climate, and ocean services. And that's a quite good success that we see. The way actually some of the countries like Dominica, St. Kitts and Nevis are actually moving forward to interoperability space, integrating data into their impact-based forecasting space, which is quite praiseworthy. And there are lots of other initiatives like Cruise from WMO, RIP from IFRC, and focus-based financing, and FPF and others. They're working on that particular field. So obviously, we need to understand our value domain when you look at the early warning system. So understanding your Earth observation to your business continuity, because end of the day, what you spend, you need to ensure your government or taxpayer, the money is worthy and money is spending right. And similarly, at the same time, as a domain expert, we need to also understand the other domain value chain, because as an early warning expert, if I don't understand what are the data value chain and how actually I should utilize our data value chain into our domain, and if these are not actually has a common linkage, you're missing actually many of the puzzle in your equation. So how we actually better actually marry with other domain, especially with the data domain, is quite important. And finally, some of the good practices that IRDR doing some fascinating work from since 2015. Since Sendai, we try to make it quite a standardized on lost data and damaged data collection system. I would just mention about the Design Center, but there are also a lot of other actually platforms nowadays exist. So we are actually talking about how those all platforms could actually cross together into one single platform so that they can talk to each other and come back to a common interoperability framework. And also the data governance system, because data you collect from today and data you collect from tomorrow, it has actually different natures. We need to understand the data of the data ecosystem, because the data that in the preparedness space you are collecting, and if that same data would be collecting for the disaster response space, is actually a different data set. So those are not common. So we need to make sure that what data, when, how we are actually collecting to different disaster space to making sure our damage assessment quite good. And obviously there is a big work has been done to definition vocabulary. We try to use this as a definition and vocabulary. It's a 1,000-page document. I emphasize that we should actually use this as a good practice. And finally, if we want to introduce our impact-based forecasting, we need to have such kind of platform, which also work that IRDR and CODA is supporting to the countries to develop using the satellite-based dataset or ARC database, which is quite fair, to how that could be integrated with early warning to generate some real-time damage information so that our disaster manager know that which road they should evacuate, how they should evacuate, which shelter they should go for a safe evacuation, and they make sure that their people are actually safe and return back safely. I think that's all I like to say in my talk. Thanks, Rajib Shah. Probably I able to finish within 6 minutes.
Thank you very much, Bapon. As always, very, very impressive and very illustrative presentations with lots of contents. Thank you so much. Just before I request our next speaker, just one clarification from Chunli. It seems that we will be a little bit over time. Is that like how much extra time we are allowed to be over?
Well, the session is time is set by the oral secretariat, but I think if we go 10 minutes more, it should be okay.
Thank you.
I hope Wang is noted has noted this time. Thank you.
Sorry, yeah, thank you very much. And our next speaker is Professor Wanli Wang, and very important topic of knowledge service approach for disaster risk reduction. Over to you, Professor Wang.
Thank you. Thank you. Okay, I share my screen. My topic is about knowledge service approach for DRR. So firstly, I want to share with you some progress of my team with pictures. So first story is about land degradation. Land degradation is also a kind of ecological disaster in arid or semi-arid region in Mongolia Plateau, for example. We use remote sensing to get the 30 years period land degradation and restoration stages every 10 years. So we can see when and why the land are degraded and when and why the land are recovered. So it's evidence for the policymakers. And this story is use another kind of big data resources is paper literature resources. We use their abstract to get why the authors are paying more attention to this region to study the flooding issues. And also we use an emergency database to get the real disaster location data. So we can couple them together. We can see that there exist some gaps in some region. For example, Europe, in West, Central, and East. So, and also in the Latin America and the Caribbean Sea, we also can see some difference there. So research hotspot and the flooding hotspot is different big data. And this slide shows we use social media like Chinese Twitter, Xinjiang Weibo's message. We use this text message to get the people's feeling, and their feeling, the different opinions, they are transform from one opinion to another opinion, and with the transforming, they have different location change. So we link them together. Okay, here is a general idea about using big data and for disaster risk reduction. And also we come into a rich world, data world. We have the long time monitoring data, but the data comes in all shapes and sizes. Currently, for science research, we have some data journal. They also publish data when people publish the academic paper. They also push the data paper. And also we can see the data repositories in the world. This is a Germany website about the repository, but this is also uneven in the world. We can see West countries have more repositories, but in East and also in some other places, a very, very, very low number. And as other scholars mentioned, the remote sensing data, we can get them more than before. And also we can use the high resolution or high temporal images to get the disaster information in real time. And also SynLab framework mentioned the social media data can be used for DR. So here we can see we have much more resources in social media. Here is a tool that SynLab framework recommended using for mining this information. Also, we use this method to get the distribution in China, and also we compare different resources. One is from the portal, news portal, social news portal website. One is from the professional website. We can compare them. So this is also evidence to show the social media information can be used for DR. Okay. Then talk about some idea about the knowledge service. So from facts, data, information, knowledge, and So this is a process, but in the when we talk the knowledge, we always concern the future and the local scale. So this is a challenge. Okay, knowledge service is oriented from library science, but it's now used everywhere beyond the data service, information service, and knowledge service. So they have four important elements. One is knowledge source, one is knowledge processing, and then knowledge organization and knowledge application. These are four features, for them. With the requirement of UNESCO's DR mission, so we built the disaster risk reduction sub-center in ICAST, Category 2 Center in UNESCO since 2016. Here is our workflow to build this knowledge service. So the first step is in the left and up place, a standard. So we build the method standard firstly. In this week, I also see a paper in Nature about talk about method is the basis for data sharing. So the first step is the framework, and then we build some tools and platform here, and then we make a portal to release them. Here is our online application, totally about 21 currently. Every application is like an app, so people can visit them online. Here is an example. We release the global earthquake daily mapping. Every day in 24 hours, we update it. Here is our China's historical map about disaster. We show them and make them be overlaid by other special data. Here is institution distribution mapping. And also for Pakistan earthquake in this summer, we built a website for flooding data sharing in our knowledge service platform, and we released the urgent remote sensing data. We get the flooding region, flooding buildings, flooded farmland and roads. We released the data in the website, and also we built another column about the China national experiments in nature disaster relief. Okay, then we continue to study the knowledge graph for the disaster. For example, for flooding disaster research, we use literature resources. More than 14,000 papers are collected about the flooding disaster. Then we can find the links between among these papers and make the triples of the concept. Then we can build a knowledge graph about the flooding. This is a continuum. This work is continuum. So for the future, I think ongoing work is concentrated in these three words. Knowledge service and data intensive science and big data driven disaster risk reduction. This is the vision, I think. But thank you all for giving me this chance, and also I can learn from your practice. We can cooperate to do this research. Thank you.
Thank you very much, Professor Wang, for this very, very informative and illustrative presentation, and so much of amazing information you have in your portal. I hope that we have more users for that. Thank you so much. So we are 4 minutes past our schedule, but if there is any specific one or two questions, I see in the chat box there were some communications and ongoing. So thank you very much for that. And any specific question to any of the speaker, which has to be very brief, or any comment, overall comment? Anybody?
Rajiv, I already discussing this thing with Professor Sujuli, so I don't want to take up any time.
Maybe you can discuss with her a little bit later, as she has written bilaterally, and that's a very important topic. Thank you. Any overall comment, anything? If not, let me just try to, Chunli, is it okay that I summarize a little bit, or you want to have any specific comment?
No, please go ahead,
Okay.
Rajiv.
So what I heard is that that's a very important point which are coming out from all the illustrative presentations. The one point is that our risk landscape is very much changing, and that's how this whole concept of data, importance of data, is also changing and getting more important day by day. I think that data for whom, from this particular presentation, I saw at least the three levels. One is, of course, for the people and community to engage and to get benefit from the data sharing. Awareness as well as understanding on the incentive is very important. So one is definitely data for the people and community. Then for the local and national government, which is required for the decision making, but which also needs lots of capacity building and knowledge service provisions, which we heard from several presentations. And the third point for data is at the regional level. I think this cross-boundary data effectiveness is extremely, extremely important. So community, local to national government, and at least at the regional level. So at these three levels, data becomes extremely important. And of course, it's not just the government, all the other stakeholders like science, technology, private sector, civil society, they play equally important role on this whole process. Now, three specific key messages. There are many messages, and I'm possibly not that expert on this topic to tell that these are the three specific things. So please forgive me. There are many, many important messages. But to me, I think three specific things which came out very strongly. I think this Earth observation data becomes not only important, but very essential when it is for the remote areas, like the reservoir management or the ice lake or the Gulf risk management and so on. It has to use the Earth observation data, and we have seen very specific illustrative examples of that in China, in Himalayas, in Afghanistan, Pakistan border areas, and so on. That's number one. Then second is this, we talked about quite a bit on the open data, and in this whole discussions, I think this open data also needs a very strong governance support, and which is not just the technical aspect of the open data, but more clearly, we need legal and the governance aspect to deal with, whether it is the national governments or whether it is the cross-boundary regional governance part for this open data. And number three is citizen science, or the people-led science that plays really an important role, and increasingly it is recognized in the risk reduction, but it needs also a little bit of hand-holding, where people need to see clearly that they, being the part of this process, there are very specific incentive to them. I think that's a very important part. And I think the overall message is that data are not just number. It is important that how we turn that data into information, information to knowledge, and finally from knowledge to action. So that this particular link from number to action, I think extremely, extremely important. Again, I apologize that this is a very, very vague summary of the very rich presentations which we had. I'm sure that there are lots of other, many other takeaways, but I thought that to highlight all these particular points. I also see Virginia to be here. So thank you very much, Virginia, to be present here. Since you are here, we can't let you go without telling, at least saying one or two words or one or two sentences.
Oh, Rajiv, I just can't tell you how exciting it is to be back having a DBAR call again and to see so many wonderful friends and the incredible work that they're all delivering. I have absolutely loved this session, and it's so good to be involved. And Bapun is bringing together all the hazard information profiles that is so key to all the work that you've all contributed to. I suppose to me, the one thing that I feel is really lovely is not only congratulations on your prize, Rajib. It was lovely to see you get the award at the global platform. That was really exciting. But it's also knowing that we're also committed to making science available, useful, usable, and used to all that need it, and that we're all there to work together. And I can't thank you enough for this opportunity to be part of it. It's just tremendous. Thank you for allowing me to say a few words, Rajib.
Thank you. Thank you very much, Virginia. So with that, I think, yes, we are 9 minutes past the timeline, but I thank all of you for these excellent presentations. And I hope that these will be available in the websites. Is that so, Fang? Yep. Some of the presentations, or at least our internal sharing, if there is any ways. So, yes.
Just say, as we are promoting the open sharing culture, I hope that all the authors of the presentation can share with the PDF after you check again, look at your material, and then we will make it at least to share with the group so that the rich knowledge and information that will not be lost for that. And I think the Secretariat will also, based on your presentation and also the summary that Rajib has just made, and to send you a summary note about the session, and then all dear colleagues can make some corrections and suggestions so that we have a good record of the output of this session, apart from what is recorded over there. Just in 5 minutes, I think there will be a closing ceremony. So I stop here, Rajib.
Yes. Thank you. Thank you very much. And I really like the work of also Professor Wang. And I think that needs to be disseminated more widely. I'm sure that many people doesn't know that huge database which he has. And it will be so useful for different parts of the world. So somewhere possibly we need to think it strategically, some collaboration with IRDR. Thank you very much, Professor Wang, for this excellent
Thank you.
Yes, thank you. Thank you very much. Very good to see at least your faces. And hopefully someday we will meet in person soon. Thank you. Thank you very much.
Thank you very much.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Bye-bye. Thank you, Rajib.
Bye.
Thank you, Virginia.
Thank you.
Rachel, Amot, Dr. Wang,
Bye.
Dr. Lee,
Bye-bye.
Thank you. All the best.
Thank you.
Bye-bye.
Thank you.
Bye. Bye-bye.
Bye.
Recording stopped.